Computing mathematics, especially the use of matrices, is very important in modern problem solving and technological innovation. Matrices provide a structured way to organize and process larger amounts of data, allowing computers to perform complex calculations quickly and accurately. In manufacturing, metrics are used to arrange information such as cost, profits, and limited resources. For example, management must decide how many units of each product to produce in order to maximize profit while staying within resource limits. By modeling constraints like raw materials, labor, and machine time in matrix form, companies can calculate the best production plan. The approach not only saves time but also reduces the risk of error. As a result, matrix becomes a powerful tool for making strategic decisions efficiently and effectively in modern industries.
I wanted to explain how to make mathematics, especially when traces is applied in your life. First of all, matrix are a rectangular arrangement of numbers that are organized in both in a computer. Metrics are very important because they help computer process a large amount of data quickly and accurately. Next, metric can be used to represent data in businesses such as production, resources, and profit. For example, company produce two products, product A and product B. The number of units produced can be represented using a production vector, while the profit per unit can be represented using another vector. In addition, by using metric multiplication, the company can calculate total profit easily. For example, when the company produce 20 units of product A and 50 units of product B, the total profit earned is Rn 850. This shows that matrices help company make faster and better decision.
Next, discuss the problems without the use of computing mathematics. What difficulties arise? Difficulty managing complex production data. Manufacturing companies typically make several products by using various resources. So, without matrix, data has to be calculated by hand or in separate steps. This makes the planning process slower and leads to messy information. Next, high risk of errors in manual calculations. As the number of products and available resources grows, the complexity of calculations increases. Handling this task manually raises the risk of errors and leads to inconsistent data. It becomes difficult to understand how resource use affect the amount of products produced, resulting in weak analysis and ineffective planning. Next, inefficient handling of production constraints. It is difficult to manage limitations like labor availability, machine hours, and raw material supply all at once, which can result in production decisions that are not entirely accurate or comprehensive. Next, how would decision-making, prediction, or optimization be affected? First, poor decision-making. Decisions are made based on experience or assumptions rather than using data. It is challenging to identify the most suitable production volumes. There is a risk of not achieving the highest possible profit given the available resource. Next, with prediction and optimization. It is difficult to foresee the effects of alterations in production amounts, variations in resource costs, and changes in customer demand. The connections between products that use the same resource are not clear. Optimization ends up being a process of trying different approaches rather than using data to guide decisions. What inefficiencies or errors might occur? First, inefficiency use of resource. Raw materials may be waste or used excessively. It is possible that workers and machines are not utilized to their full potential. Inadequate production schedule planning can result in increased expense. And next, profit and operational issues. Producing an excessive number of low profit items, not producing enough of more lucrative goods, missing delivery dates and production delays, and inability to swiftly adapt to shifts in consumer demand.
Next, I will present the creative improvement solution using current technology for this project. The proposed solution is an AI-based smart production optimization system that combines matrix mathematics with modern technology to improve product production and profit in a manufacturing company. First, I will explain how technology integrates with matrix computation. Artificial intelligence is used to analyze past sales data and predict future demand for each product. The predicted values are stored as a production quantity vector. At the same time, the usage of resources such as raw materials and labors are represented in a matrix, while the profit per product is represented in a profit vector. Using matrix calculation and optimization software, the system will automatically determine the best production plan to optimize the profit while respecting resource limits. Next, the solution improves the situation by making production planning data-driven instead of manual. It helps reduce overproduction and material wastage, saves time through automation, and minimizes human calculation errors. As a result, the company can use its resource more effectively and gain more profit. Finally, this solution is realistic and useful because the technology used such as AI, Python, MATLAB, or Excel that are widely used in manufacturing companies today. The system is so easy that we can change the demands and both can apply in small and large companies.
In conclusion, metrics not just theoretical concepts but practical tools that drive efficiency, accuracy, and innovation. They help computers organize data, solve complex equations, and support applications like image processing and production optimization. Without them, industries risk mismanagement and poor decision making. With modern technologies such as AI, IoT, and cloud computing, the potential of metrics is amplified, enabling smarter decisions and sustainability growth. That brings us to the end of our presentation. We hope this has given you a clear understanding of how metrics are applied in computing mathematics and why they are important in today's digital era. That's all from us. Thank you.